Hello guys, I hope you will be alright. This is my very first video on software engineering and I will start narrating this software engineering book written by Summer Vele. So we are going to start. There is the structure of the book in which he described that there is 7 parts and each part focuses on individual department of software engineering processes, and then changes from 7th edition because it's 8th edition. There is a readership, choosing the book for teaching only, web pages, acknowledgements, and then overview. In this video we will go through the book in very short manner, and later on we will briefly start working on each chapter. So part 1 is overview, introduction, socio-technical system, critical system, software processes, project management, and then requirement section, software requirements, requirement engineering process, system models, critical system specification, formal specification, and then part 3 is design, architecture design, distributed system architectures, application architecture, object oriented design, real-time software design, and user interface design. Part 4 is department development, rapid software development, software reuse, component based software engineering, critical system deployment, development, software evolution. Part 7 is verification and validation, which is, and then software testing, critical system validation, management, managing people, software cost estimation, quality management, process improvement, configuration management. Managing technology covers security engineering, service oriented software engineering, aspect oriented software development, and then these are our part 1 overview. In overview, the objective is very clear: understanding what software engineering is and why it is important, know the answer to key questions that provide an introduction to software engineering, understand some ethical and professional issues that are important for software engineers. There is a content, and there is a facts about software engineering. What is software engineering? There is multiple questions. One is what is software, what is software engineering, what is difference between software engineering and computer science, what is difference between software engineering and system engineering, what is software process, what is software process model, what are costs of software engineering, what are software engineering methods, what is CASE, computer aided software engineering, and what is attributes of good software, what are the key challenges facing software engineering. So these are the facts. What is software engineering? Software engineering is an engineering discipline that is concerned with all aspects of software production, from early stages of system specification to maintaining the system after it has gone into use. In this definition there are two key phrases: one is engineering disciplines and one all aspect of software production. And this is what is difference between software engineering and computer science. These are the answer to the facts. We will go through all of these later on coming videos. What is software process, and then what is software process model. Let's discuss this thing that is seems very interesting. Like, a software process model is simplified description of software process that present one view of that process. Process model may include activity that are part of the software process, software products, and the software process, software product, and the role of people involved in software engineering. Some example of type of software process model that may be produced are a workflow model, a data flow or activity model, and then a role or action model. Workflow model is they show the sequence of activities in process along with their inputs, output, and dependency. The activity in this model represent human action. A data flow or activity model, this represent the process as set of activities, each of which carry out some data information. It shows how the input and it shows how the input to process such as specification is transferred to an output such as design. The activity here may represent transformation carried out by people or by computer. A role action model, this represents the role of people involved in software process and the activity for which they are responsible. Many software process models are based on one of three general model or paradigm of software development. One is the waterfall approach, iterative development, computer-based software engineering. Waterfall approach. This take above activity and represent them as separate process phases such as requirement specification, software design, implementation, testing, and so on. After each stage is defined, it is signed off and development goes on the following stage. Iterative model, this approach interleaves the activity of specification, development, and validation. An initial system is rapidly developed from very abstract specification. This is then refined with customer input to produce a system that satisfies the customer's need. The system may then be delivered. Alternatively, it may be re-implemented using more structured approach to produce a more robust and maintainable system. And thirdly is component-based software engineering. This technique assumes that part of system already exists. The system development process focuses on integrating these parts rather than developing them from scratch. I discuss CBC in chapter number 19. I return to these generic process model in chapter 4 and 17. These are the reference to the chapters. What are the costs of the software engineering? And there is again a fact which is frequently asked questions. In waterfall model, there is specification, design, development, integration, and testing. It is a cost of software engineering. And in iterative model, there is a specification. We will dedicate some budget for specification. Then there is iterative development and then system testing. CBSC involves specification, development, integration, and testing. And the final is development and evolution cost for long lifetime. There is a system development and system evolution. And then what is software engineering method? A software engineering method is a structured approach to software development to aim to facilitate the production of high quality software in a cost effective way. Methods such as structure analysis and JST were first developed in 1970s. These models attempted to identify the basic functional component of system. Function-oriented methods are still used. In 1980s and 1990s, these function-oriented methods were supplemented by object-oriented methods such as those proposed by Bosch and one of the scientists, Rambog. These different approaches have now been integrated into a single unified approach built around the Unified Modeling Language (UML). And there is a specification, development, system testing, and method components. There are 4 components. There is no ideal method, and different methods have different areas where they are acceptable. For example, object-oriented methods are often appropriate for interactive system, but not for system with stringent real-time requirement. All methods are based on the idea of developing model of system, and that may be represented graphically, and using these models as System specification or design method include a number of different components. What are the components? One is system model description, then rules, recommendations, process guidance. In component system model description, which is first component, what is this description of the system model which should be developed and the notation used to define these models. For example, object model, data flow model, state machine model, and then rules, recommendation, and process guidance, which we will cover these in later on. What is case computer aided software engineering? Cover a wide range of different type of program that are used to support software process activities such as requirement analysis, system modeling, debugging, and testing. And then there is what are the attributes of good software? It should be maintainability, dependability, efficiency, and usability. What are key challenges facing software engineering? There is a number of important challenges which software engineers might face. The last one is trust challenge, the delivery challenge, the heterogeneity challenge. These are the basic challenges. Then professional and ethical responsibility also need to be covered in this whole process of software engineering. Confidentiality, compliance, intellectual property rights, computer misuse. These are the professional and ethical responsibility of any professional who is working as software engineer. And this is I think end of chapter number 1, the introduction. So these are the key points which we cover in chapter number 1. Then there is exercise making reference to distribution of software cost, discussing section 1.1, explain why it is appropriate to consider software to be more than program that can be executed by end user of a system. What are the differences between generic software product development and custom software development? And after we will narrate the whole book chapter by chapter, then I will try to do these exercises with you guys. Let's overview the question number 1.9. For each of the clauses in the ACM or IEEE code of ethics shown in figure 1.6, suggest an appropriate example that illustrates that clause. Okay, 1.6, let's see what 1.6 is all about. Yeah, this is 1.6 figure. So this is ACM IEEE CS Joint Task Force on Software Engineering Ethics and Professional Practices. And now moving on to chapter number 2, socio-technical system. In this chapter, emergent system properties, system engineering, organization, people and computer system, legacy system. These are the content which we will cover in this chapter. One is emergent system properties, the complex relationship between component and system mean that the system is more than simply the sum of its parts. It has properties that are property of the system as a whole. These emergent properties cannot be attributed to any specific part of system. Rather, they emerge only once the system components have been integrated. Some of these properties can be derived directly from comparable properties of subsystem. However, more often they result from complex subsystem interrelationship that cannot in practice be derived from the properties of the individual system component. An example of some emergent properties are shown in figure 2.1. This is the figure 2.1. For example, volume. The volume of a system, the total space occupies, varies depending on how computer assemblies are arranged and connected. Then usability. This property reflects how easy it is to use the system. It depends on the technical system component, its operators and its operating environment. Okay. Then there is two major properties: functional emergent properties and non-functional emergent properties. We will cover this in later sections. There is figure 2.2, the system engineering process. So requirement definition, system design, subsystem development, system integration, then system installation, system evolution, system decommissioning. Okay, then there is system engineering. System engineering is the activity of specifying, designing, implementing, validating, deploying, and maintaining socio-technical systems. So here is a figure 2.3, discipline involved in system engineering. So ATC system engineering, for example, air traffic controller system. So what are other disciplines involved in ATC? One is software engineering, electronic engineering, mechanical engineering, user interface design, architecture, electrical engineering, civil engineering, and structure engineering. We will again repeating in detail narration of the book. System requirement definition. Then there is again the system design process. One is partition requirement, identifying subsystem, assign requirement to subsystem, specify subsystem functionality, define subsystem interfaces. And with the system design, we have another figure, a spiral model of requirement and design, stars, and then in very first quarter we have architecture design, and then review and assessment, problem definition, requirement illustration and analysis. A simple burglar alarm system which involves the door sensor and movement sensor which are connected to alarm controller. At the same time, when the alarm controller is attached with siren, voice synchronizer, and telephone caller. Then again there is a system modeling. Let's see if we can do in different format. Anyway, so guys, there is a system modeling, movement sensor, door sensor, alarm controller, siren, voice synchronizer, and telephone caller. These are the subsystem description in the burglar alarm system, and this will make a whole system that work together to fulfill one particular task. The subsystem development also is very important and need to be considered. And architecture model of an air traffic control system, radar system and transponder system, data communication system, aircraft communication system, telephone system. And there is a number of other block diagrams which we will discuss, that how there is a relationship between all of them. System integration, system evolution, and system decommissioning are the major concern of this chapter. Organizations, people, and computer systems. Socio-technical system or enterprise system that are